Okay, now let's talk about noise and vibration. Um, in many cases, designer and engineer makes mistake here. As a result, we have high noise and vibration. And we do not want to have noise and vibration in our project. If there is any vibration detected, it is going to result a high amount of rework, which we really want to avoid. We are talking about the connection of centrifugal fan in this particular scenario. Centrifugal fan are commonly used in HVAC system. Let's say we use centrifugal fan in our fan coil units and air handling units, also and at the fresh air units. Wherever, it doesn't matter. Whenever we use a centrifugal fan, we must be careful about some basic or fundamental um, norms. Now, this particular discussion is directly from ASHRAE Handbook of Application, Chapter 48. Here we have centrifugal fan. There are 6 scenarios here. The scenario number 1, scenario number 2, and scenario number 3 are the ideal scenarios. And scenario number 4, scenario number 5, and scenario number 6 are not recommended by me and also by ASHRAE. Okay, let's look at the optimum scenario. Scenario 1, 2, 3. The first scenario, the optimum scenario, what is happening here? Here in this scenario, the centrifugal fan is throwing the air at a horizontal direction. And the scenario number 2, which is a very good connection, where centrifugal fan is throwing the air at an angle. And at the scenario number 3, the centrifugal fan is throwing the air at upward motion, and we are going to have a 90-degree elbow here. Okay, let's talk about these first 3 scenarios. At the scenario number 1, here we have the centrifugal fan. After centrifugal fan, there will be a canvas connection or whatever you use for a flexible connection here. And after that, we are going to have a straight length of A. Then what is A and how long should be the straight length? For instance, let's say this is the opening of the centrifugal fan you have. And the size of the centrifugal fan opening should be maintained for a length of 1.5 of B. So this is the length. This length A is equal to 1.5 of the B. Then what is the B? B is the largest discharge duct dimension. Let's say the largest discharge duct dimension is 10 inch. In that scenario, if B is 10 inch, the A is going to be 1.5 into 10 is 15 inch. The largest horizontal is quite like a plenum. Okay, after this, the straight length, you keep the same length as the opening of the centrifugal fan. After this, we are going to have a connection with the main duct. The main duct is sized as per your volumetric calculation requirement here. Now, there is also a requirement of the slope. The slope that we need to maintain here is preferably 1 inch every 7 inch. Now, if you do not maintain, this is the preferable one. However, if the duct velocity or the velocity here is less than 2000 feet per minute, in this scenario, you can actually have a slope 1 inch every 4 inch of a straight duct. Scenario number 2 is similar to scenario number 1. And at the scenario number 3, the air is throwing, the centrifugal fan is throwing the air as vertical motion, and you're going to have an elbow here. The elbow that you're going to have here must have a radius minimum 6 inch. The radius minimum is 6 inch. If you have more than 6 inch, no problem. Less than 6 inch is a problem. So if it's less than 6 inch, you might face noise. And in this particular scenario, you must have required number of vents inside the elbow to avoid noise. If you have a sharp elbow in this scenario, if elbow radius is less than 6 inch, it is going to make noise. So you have to avoid this particular scenario. The sharp elbow and sharp elbow will always make noise. So you have to avoid this. This is the optimal scenario, very good scenario, and good scenario. These are the scenario that we are going to follow. However, in many cases, I have seen mistakes. There are common mistakes. What I see in my observation is like this. The engineer or designer at the connection here, they have the flexible duct, and suddenly, without getting into this horizontal direction straight, they make it larger. This is a mistake here. You shouldn't do this. And the second mistake that I see usually is about the slope here. Sometimes we make a very sharp slope. Very sharp slope is not welcome here. The details is in here. If the velocity is less than 2000 feet per minute, we are allowed to have a sharp slope 1 inch every 4 inch. But preferably it is 1 inch every 7 inch. If the velocity is more than 2000 feet per minute, we have to follow this. There is no other options. Third mistake is about the radius. Yes. So if we have a connection like this, after fan, we have a elbow. I have seen many times the radius of this elbow is not maintained. As it is mentioned here, minimum 6 inch radius is required. Okay. This is the third mistake. And the fourth mistake we have, even the radius is there, 6 inch or more, we do not have the vane inside. If we don't have the vane inside here, we are expecting noise. So as a certified HVAC designer, you have to be careful about these connection details. So your design will be better. Perfect. Yeah. Let's move forward with the next segment. And if you have a question here, you can raise your voice now.